Hello students, welcome back to Future Foundation. In last class of vectors, we have discussed some properties of dot product and questions based on them. Now in today's class, we will do some more questions using dot product. So let's start the class. Question is, a line is passing through A having position vector 1, -2, -1 and parallel to vector B 1, -2, 2. Find distance of a point P 5, 0, -4 from the line, and also find position vector of reflection of point P with respect to line or given line, right? तो यहाँ पर हमको क्या दिया है और क्या फाइंड करना है वो देख लेते हैं. से बेटा एक गिवन लाइन है, ओके, वो एक पॉइंट ए से पास कर रही है जिसका पोजीशन वेक्टर गिवन है, और फिलहाल कह लो ए के लिए पॉइंट गिवन है स्पेस में, ऐसा भी कह सकते हो, कोई दिक्कत नहीं है. अब एक तो ये चीज़ हो गई कि लाइन पॉइंट ए से पास कर रही है, एंड इट इज़ ऑल्सो गिवन दैट line is parallel to vector B, okay, and this is vector I cap minus 2j cap plus 2k cap, or I can say 1 minus 2 2. ठीक है बच्चे. Now what we have to find, distance of a point P, distance of a point P having position vector 5, 0, -4 from the line. We have to find this distance, say PM, and also find position vector of reflection of the point P with respect to line. Say if I extend beyond this M in opposite direction, so say P dash is reflection of P, and say this is alpha, beta and gamma, so I also have to find this alpha, beta, gamma. So these two things I have to find. So let's start. First of all, for this, what we will do, let us take parametric coordinates of a line. So if a line is passing through, if we write equation of line, so equation of line is x minus 1 upon 1 is equal to y plus 2 upon minus 2 is equal to z plus 1 upon 2. So from here I can write parametric coordinates. So if I take this whole is lambda, so x will be lambda plus 1 minus 2 lambda minus 2 and 2 lambda minus 1, right? If these parametric coordinates belong to M, so M is having these coordinates, or PM vector. If I need to find PM vector is nothing but position vector of M minus position vector of P, and it will be lambda plus 1 minus 5 comma minus 2 lambda minus 2 minus 0 comma 2 lambda minus 1 plus 4. So this is lambda minus 4 comma minus 2 lambda minus 2 comma 2 lambda plus 3. Pm vector dot B vector is equal to 0 because B vector and Pm vector are perpendicular. So lambda minus 4 comma minus 2 lambda minus 2 comma 2 lambda plus 3 dot what is B vector? 1 minus 2 2 1 minus 2 2 is equal to 0. So from here I can get lambda. So this is lambda minus 4 plus 4 lambda plus 4 plus 4 lambda plus 6 is equal to 0, or 9 lambda plus 6 is equal to 0. So lambda is equal to minus 3 minus 2 by 3. So if you have lambda, then you have complete m independent of lambda. So m will be minus 2 by 3 plus 1 comma minus 4 by 3 minus 2 comma minus minus 1. So m becomes 1 by 3 comma minus 2 by 3 comma minus 7 by 3. So now you can have Pm, distance of point P from line, by using distance formula, which is 5 minus 1 by 3 whole square plus 0 plus 2 by 3 whole square plus minus 4 plus 7 by 3 whole square. Okay, now you can calculate easily. And now I have to find one more thing also. P dash means reflection of P. So you know very well, reflection is the distance, is same distance as it is from line. Reflection of point P is at the same distance from the line as point P from the line. So you can say M is midpoint of PP dash. So by using midpoint concept, you can get coordinates of P dash also. So using midpoint formula, that is 5 plus alpha by 2. 5 plus alpha by 2 is equal to what? 1 by 3. So 5 plus alpha is equal to 2 by 3, or alpha is equal to 2 by 3 minus 5. 0 plus beta by 2 is equal to minus 2 by 3. So beta is equal to minus 4 by 3. And minus 4 plus gamma by 2 is equal to minus 7 by 3, which is gamma is equal to minus 14 by 3 plus 4. So now you have alpha, beta and gamma as well. So your problem has been solved. Now students, let us come to next question. Question is, if A is greater than 2 in triangle A, B, C, A, B and C are variable angles such that root over a square minus 4 to tan a plus a tan b plus root over a square plus 4 into tan c is equal to 6a. Find minimum value of summation tan square a. Okay, students. So this question is of three variables, that is a, b and c, and you have only one equation. So using vector I will do this problem. So let E vector is equal to root over a square minus 4 I cap plus e j cap plus root over a square plus 4 k cap, and b vector is equal to tan a I cap plus tan b j cap plus tan c k cap. Also E vector dot b vector is mod of a vector into mod of b vector cos theta, and if you take a vector dot b vector then you will get root over a square minus 4 tan a plus e tan b plus root over a square plus 4 tan c, which is equal to root over a square minus 4 plus a square plus a square plus 4 to root over tan square a plus tan square b plus tan square c into cos theta, right? And now it is, if we are seeing LHS, so it is 6a. 6a is equal to minus 4 plus 4 cancel out, root over 3a square, that is root 3a times root over sigma tan square a into cos theta. So this will be 2 root 3 is equal to root over summation tan square a cos theta, or after squaring this will be 12 sec square theta is equal to summation tan square a. Summation tan square is nothing but tan square a plus tan square b plus tan square c. So summation tan square a minimum is equal to 12 because sec square theta is less than, is greater than or equal to 1. As sec square theta has minimum as 1, so summation tan square a has minimum as 12. So the question has been solved using vectors very easily. Now let's come to next problem. Using dot product, prove that in triangle ABC, first A is equal to B cos C plus C cos B, which is projection rule. You have studied in properties of triangle this rule. And second, cos A is equal to b square plus c square minus a square upon 2bc, which is cosine rule. This rule has also been discussed in class 11 in chapter properties of triangle. Now, so using vectors or using dot product, I have to prove these two things. So let's try. Now, ABC is a triangle. So ABC is a given triangle. This is A, this is B, and this is C. So this is A vector, say this is B vector, and this is C vector. You can say. So we know A vector plus B vector plus C vector is equal to 0, right? Now, taking dot product with A vector, both sides. So A dot A vector plus B vector plus C vector is equal to A dot 0, that is 0. Now A dot A, that is mod of A square, plus A dot B plus A dot C is equal to 0, or this mod of A square plus A B cos angle between A and B is pi minus C. I have discussed this thing in the very first lecture, that when we see angle between two vectors, then rays must be discreted. Angle is formed where rays are discreted. Okay, so I think this thing is not bothering you. So this is pi minus C. Similarly, E dot C is mod A plus mod C to cos angle between A and C is pi minus B is equal to 0. So A common, so mod of A plus cos pi minus C is minus cos C. So minus mod B cos C minus mod C cos B is equal to 0. Or if I write mod of A vector as A vector, sorry, mod of A vector as A only, so it represents magnitude also. So A is equal to B cos C plus C cos B, and hence proved. Now come to the next question or next part. Again, A vector plus B vector plus C vector is equal to 0, right? So I have to make B square plus C square minus C square upon 2BC is equal to cos A, right? So what is the strategy, or what is the thought to prove this thing? Again, so if I write A vector is equal to minus of B plus C and then take squaring, so this thing will become like this thing, or after squaring this will become this mod of B square plus mod of C square plus 2 B dot C, or mod B mod C cos theta, and theta is the angle between B vector and C vector, B vector and C vector. So angle between B vector and C vector is pi minus A. This is cos pi minus A, and cos pi minus A is minus cos A. So I am writing this mod of A vector as simply a is a. So this is a square is equal to b square plus c square minus 2bc cos a, right? Or I can write b square plus c square minus a square is equal to 2bc cos a, or cos a is equal to b square plus c square minus a square upon 2bc, and which is the required proof. Okay, so hence root. So students, this was all about the current lecture. Let's meet in next class. तब तक के लिए bye bye and take care. Thank you students.